Hello and welcome. I'm very happy to be here to talk about the new release of MapleSim's Web Handling Library, release 2023.1. Let's Before we get to the new features for people who might be new to MapleSim or the Web Handling Library, I wanted to give an overview of the environment that we are using to do various types of converting and role simulation, and that is MapleSim, which is a system level modeling environment. MapleSim comes with a number of libraries, component libraries that cover various fields of engineering. And one of those libraries is the Web Handling Library, which will be the focus of this talk. MapleSim is then paired with Maple, which is the environment for doing numeric and symbolic math. And within the context of MapleSim, Maple provides an environment for scripting, engineering worksheet creation, or apps for MapleSim, pre-processing, post-processing. Unfortunately, we won't get into examples of that in this talk, but there are resources that I will talk about in a second. And the final part of this triangle would be deployment, digital twin virtual commissioning, which any model that we create in MapleSim, we can export as an FMUS function or C code, which then can be integrated to downstream applications. That also includes models in the web handling domain. For some more information, I'll recommend that if you haven't, take a look at our website. There are tons of information there on MapleSim and also MapleSim Web Handling Library. You have information, you have links to videos, recorded webinars that you can check out. And especially if you are new, as I said, to MapleSim and Web Handling Library, that would be a good place to start. And obviously, give us a call, contact us if you had questions or there's a particular application that you wanted to discuss. We do publish and post a number of videos frequently, actually. So these are just sampling of some of the videos related to the web handling. So again, this will give you more details, some deep dive into the equation behind the web handling library, some specific talks from industry standpoint, that you can find on our YouTube channel, which I highly recommend that you check them out. Okay, so let's talk about the web handling library and what is new. So the web handling library comes in subgroups of components. We have web material, web span, rollers, sources and sync. That includes the wind and unwind drum, group for laminating processes when we merge two or more web into one, and then support components such as sensors and primitive to put components at a certain location or give them different ways of motion. So the changes were for this release are in the material properties, in the rollers, source and sync, and laminating. All of these subgroups have seen additions, expansion, or new features. So the first feature would be on the web properties. Now we have a option to switch from a linear, or which is a default representation of the web, to a nonlinear one. When we go to nonlinear, the stress-strain relationship is defined by a lookup table. And that lookup table could be just typed into the user interface, or you can point to an Excel file where your experimental data is saved. Okay, so let's take a look at this in action. We'll jump into MapleSim, and for this example, I'm going to use one of the built-in examples in MapleSim. MapleSim comes with a number of examples in each of the various domains that it supports. Web handling is no exception. What we're doing here is that we have a very simple section of the web with the inlet and outlet, source and sink. And then in the middle, we have two nip rollers, two idler rollers, and one of the nips are speed controlled and the other one is torque controlled. And the idea would be to create a tension zone in the middle. And here's the result of the simulation, typical to any web handling model that we simulate. We get the 3D animation, we get the various plots of things that we care about. Here, on the top plots, we see a group of 5, which is a tension in the web spans. And bottom plot shows the stress-strain relationship, which is linear. Now, if we turn the linear option off, then we can enter the data. Here, the stress was in megapascal and the strain was in percentage. And with that, we would just rerun the simulation. No other change would be required. The material properties are propagated to the entire model or a section of model that references this web line. As you might know that in web handling library, you might have multiple webs interacting in the same model, and you will do that by referencing the right properties. So here we see we have definite impact on the tension development, and also we see the changes in the stress-strain curve, which is now clearly nonlinear. Okay, so the next feature that I want to talk about would be the eccentricity. So now in 2023.1, we have eccentricity added to a roller component, which covers both pull rollers and idlers. And also we added that to the combined component called strap rollers. So individually, you can turn on the eccentricity on this component, in this component. And also eccentricity can be activated for the wind and unwind drums. So once again, let's jump back to MapleSim and see this feature in action. Another example from the example palette. This time we go to disturbance propagation. The idea here is that we have a group of 4 pull rollers all under speed control, but one of them, the last one, roller number 4, is suffering from eccentricity, which was activated by the eccentricity option. So first thing we're going to do is just run the simulation and take a look at the results. We're expecting to see the effect of eccentricity on the tension. And since some of you might have already noticed that all of these rollers have a slippage activated, the web slips and the tension variation travels upstream. And we can see that in the span that is being selected, span number 3, that clearly there is significant variation in tension. And if we take a closer look at the roller with eccentricity, it is intentionally selected as a large number so that we can see it in 3D. Now, there are different ways of dealing with this. If assuming we cannot fix the actual roller, then for demonstration purposes, what we're going to do here is that the roller immediately upstream to the one with eccentricity, we will add a vacuum to it to increase the traction and to separate, hopefully, the upstream from the disturbance generated at downstream. So we'll just do that. Here it recommends a number in the annotation. We'll just enter that and rerun the simulation. Notice that I've saved the previous results so that I can do a comparison between before and after. So we'll see if we were successful with limiting the amount of tension that has been propagated, which is the case here. We see clearly the tension disturbances that are propagated upstream has reduced. And this also, because of the separation of spans that it creates, changes the time constant for tension development in the web line. Okay, so now I'm going to move on to the next feature, and that is a new component, not a feature, just a component, completely newly developed component for the 2023.1 version of Web Handling Library. And this is a variable nip roller, which can act as a nip roller with a slippage. So far, the nip roller that we had in MapleSim in previous releases did not include slippage. So it was always considered to have enough normal force that no slippage occurred. But if that's not the case and you want to explore the idea of what will happen if the nip slips, then this component would be replacing the already nip roller in your model. There are multiple options in this component. You can have a constant normal force between the nip and roller. You can have a variable normal force, or you can actually separate the nip and roller so to perform engage disengage task during the operation of the web line. So we'll see actually that, which is the most exciting. We'll see an example of that shortly. So let's just jump back into MapleSim. One more time, an example that is part of the package. I'm going to select this model that I'm going to show quickly. This was previously there. This is just two pool rollers and would demonstrate the capstan limit. But this one says beyond capstan limit, where we start almost identical to the previous model with the two nips disengage, which we are at the mercy of the capstan limit for the tension differences. But as we'll see shortly in the results, how nips change that. Before doing that, while the simulation is running, let's take a look at the help, where we have explanation of how the nip force is developed when you choose the option to engage and disengage. And also caution regarding the nip should be always connecting to the contact arc. And some detailed information for those that are interested in how the equations are put together, mixing the capstan and the normal force friction. Okay, so we have the results. Let's take a look. Here, as I said, at the start of simulation, it's the same as the previous example. Nips are not engaged. Then we will sync up the speed of the left nip and bring it to contact. Again, if you see that the plots, nothing is really changing because that has no effect. It was at the same velocity. Now we'll do the same thing for the right, which is faster. Now this extra friction force creates a higher tension difference between the tight and the slack side of the web in this demonstration simulation. Okay, so moving on to a couple of smaller features that were added to 2023.1. First one is the option to not use the fixed frame. If you look at the web line in the top layout, you see that the rollers and the unwind drum and the sync components all connected to a fixed frame. So there are basically two components are needed to accomplish that. And that could be tedious, create a lot more components that you would need. Obviously, when we have moving or rotating components like the dancer, we would need a fixed point. But when these components like the unwind, the sync, or the idlers are fixed, we can use the internal option to say use fixed space, where you won't need an external component to fix, and you just type in the actual position that you want in XY plane directly into the component. This would save some real estate in your canvas while you're building models, especially important for potentially larger models. The other option that was added for 2023.1 is so the library itself is designed for web lines that go from left to right. When I say design, is it can cover previous releases could obviously cover right to left web line as well, but the part that would be nice and it would be lost would be the matching of the canvas and the 3D or the actual layout. So here we see over under, web goes over the roller, under the roller, and if we want to keep the same match between the layout and the 3D, there's a new option called flip direction. So any portion of the web that goes from right to left, we will just flip the component horizontally and check the flip direction option, which also adds a tiny XY coordinates on the icon to make sure that you have also to alert you that this flip direction has been activated, and make sure that you flip the components so that the XY matches the canvas. So when we do that, this is just for organization of your model on the canvas, has no real other effect on the simulation results. And we'll see it in another example in MapleSim. Going back to MapleSim and opening yet another model. This one is right to left web line, and it includes two, basically the portion of the web. The top line goes from right to left, and the bottom one goes from left to right. And you can see that the option for flip direction has been activated on all four components on the top portion of the web, so that when we can immediately see without even simulating how the web is going over and under each of those rollers or drums that it comes to contact. It also uses the fixed space component to save up on a number of components on the canvas and have a cleaner layout. So let's just to complete this, let's simulate and see the results of this model. We have added probes to this, so we're just going to turn them on. Yeah, so we're measuring the dancer angle and one of the span tensions, this one and this one. So let's head to the results. Yeah, so with this, as I mentioned, with the flip direction option, you can maintain the one-to-one relationship between your actual web line in 3D and your canvas in MapleSim in 2D. A smaller feature that I need to also mention here is that sometimes, so the rollers, all rollers in the web handling library internally calculate the mass and inertia of the roller based on the dimensions. So there are parameters for length and outer diameter, inner diameter, and density. But sometimes you have a special shape, it might, and you want to be very exact or very accurate on the estimate of your mass and inertia, or you just want to have nicer 3D visualization. So you might choose to use an external body to represent the mass and inertia of the roller. That could be primitives, it could be other components from the MapleSim library, such as the one we're showing here, which is just a CAD import. So let's take a look at how would that be utilized potentially in a model. So we have a web line here. You see there are a bunch of components on top of roller number 4 that are deactivated. So right now we are running this model as if that option wasn't there. To take a look at the results, let me just turn that off so we can see the whole web line. We have a master speed driver and 2 torque controlled, one nip, one pull rollers here to manage the tension development in this web line. And as you can see on the left hand side, the unwind is equipped with a brake as well. So just an example of the kind of things that you can model here, but the focus here is on the option of use CAD. So simulation is done. Let's head over to the results window and take a look at the results. Okay, as typical in any simulation, we have the web line in 3D. We have various plots. Here we are showing the variation of tension in the web spans as the simulation is running. And now we're going to focus on roller number 4, this one, and replace it from an internal calculation to external calculation. So let's just do that. I'm going to turn on the use CAD option, which removes the internal parameters, and now we activate these 3 cylindrical objects that would create a non-standard shape for our roller. Just a demonstration. I didn't use CAD here, but we are using currently the machine elements component from the multi-body or we could have used the CAD geometry component, or we could just import an assembly and from the using the import CAD add-on to MapleSim, and then hook one of those CAD geometries in the assembly to this component to complete the equations of motion for the system. Yeah, so the simulation is about to finish. All of these components I'm using from the machine elements, they themselves have geometry and density. So MapleSim then sums them together and correctly accounts for the total mass and total inertia of all the connected parts. And that will affect the overall tension. So we see that here's the shape I'm using for this simple demonstration. Still a complete and correct simulation, except that the mass and inertia of this roller, it is rotating roller, is now defined externally. Now that I have this option, I can also explore things like other types of defect. We already seen eccentricity. Now, what about unbalanced roller? So I can easily do that by hanging an extra mass that is off center to this roller, and since this is an idler roller, that eccentricity would expect to create some sort of a signature on the tensions. Let's just run the simulation again and see how such a scenario or such a defect would affect or show up in the measured tensions. Here, these are simulated tensions, so thanks to simulation, we have tension everywhere. But in a real scenario, this could be also showing up on the actual measurements of tension in the web line. So the simulation almost done. And as we are going to expect, yes, we see the ripples that are added to the tension as a result of that unbalance that was added to roller number 4. Okay. So one point regarding large models, one of the other enhancements to the library for 2023.1 is that the formulation has been improved and sped up. So for large models, you see a significant difference between this release and the previous releases in much faster formulation for large models. Here we have a web line, laminating web line with 60 or 70 rollers. The point I wanted to make as to conclude this session would be, for large models, you have a lot of rollers on the screen and the canvas would be busy. So one of the things that you can do in any other domain in MapleSim, including Web Handling Library, to use subsystem. As you can see, the layout for this large model looks very compact. And this is done by grouping various pieces of the web line into subsystem. For example, we see that these boxes each include a number of rollers that are connected in a logical way together. So this way, if you take the extra step and organize your model this way, it will be much easier to track down and investigate. This was an overview of the new features in the web handling library. I will add that on our website, you will find a model gallery, which we publish models in all domains covered by MapleSim, including web handling. So be sure, if you do have access to MapleSim and the web handling library, be sure to check it out, as we often and frequently publish new models that we find our users will learn from on our model gallery. Thank you very much, and I'm happy to answer any questions.